This video, I'm just going to go all the way down to the end. So this might be too much too fast, but I'm just going to get you all the kind of the definitions of what A, B, C, and D are for our general like form of our functions, sine and cosine. So we talked about the parent functions in the first two videos. Now we're going to start talking about the shifts and the like vertical translations and all the other fancy stuff. What we used to call transformations in another class, and that's what we're going to do with our trig right now. So let's just kind of build it. We're going to say that here's our kind of like our standard form of for a sine wave. A times sine up, and then we go into here and we say bx minus c. Okay, there's for sine. Now this is our d. Now I'm just going to start listing out what the heck A is, what B is, what C is, and it's probably too much too soon. I'm not going to do it with a graph. I'm just going to kind of give it to you. So I know this will be quite a lot. Well, A, we don't actually look at A. So A is right here. A as just A. We think about this. What's the absolute value of it? And we call this the amplitude. Call it the amplitude. Maybe I throw a graph in there. What the hell? What the hell? Why am I being so lazy? So let's say we got our sine wave. I'll draw in just a fancy ass sine wave. Oh, isn't that just fancy? Oh, look at how terrible my graph is. We're going to be like, y equals sine of x. Well, shoot. Let's write it in this way. Y is equal to a times sine of x. Some frickin' number. I'm going to say the number is positive just for now for my graph. What we could say is the height here would be a. Not 1, but a. Whatever that number was, and this would be negative a. The amplitude is just from the center line to the maximum, or the center line down to the minimum, the absolute value of it, whatever that frickin' number is. Oh, let me change it. You don't like A? Let's call it 4. Oh, so how far is it from the x-axis up to 4? How far is it from the x-axis down to negative 4? It's frickin' 4, and that's the amplitude. Cool. 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 Let's talk about D. I'm going out of order. I'm not going to go A, B, C, and D. Because there's just a lot. There's a lot here. So I'm going to go to D. And D is what we call our vertical translation. Give you an example. Maybe we just we added 1 to this. So what's going to happen? Actually, let's add 2 to it, and we'll say this is 2. Well, our whole graph would just be shifted up by 2. Notice how it's still at the same spot, so this would actually go up to 6, and we'd go down to negative 2 would be our smallest point. So it's just saying take it all and just push it up by 2. Push it up by 2. And that's kind of your vertical translation. And I'm giving you too much. Oh, half it anyway. I'm giving you too much too soon, but that's okay. That's okay. We're going to break it down in the other videos. Now, B is, well, sometimes called the frequency. And we're not really going to stress too much about what that's called. We're going to stress more about this other term, and it's called the period. How long it takes to do one full cycle. But we've talked about the period, but we're going to say the period, we call it P, is going to be 2 pi, right? That's for sine of x. For y equals sine of x, the period is 2 pi. But as soon as we introduce this number being multiplied by that x, what we end up having is it's 2 pi divided by whatever that number is. Because this is going to speed up the function to doing its period. It's going to make it go faster. So if you put a 2 in there, it's going to get through twice as fast. It won't take it 2 pi to get through a period. It'll only take it pi. If we put a 4 in for B, it would be 2 pi over 4. Now it would only take half a pi to do a whole thing. While B is called the frequency, but we care more about this, the period, being 2 pi divided by the B. Now C talks about our horizontal translation. And by itself, it doesn't tell us much, but it does do something with our horizontal translation. It translates to things shifting left and right. Shifting left and right. But we have another thing, just like the period and with B, where we're like, yeah, B's cool and all, but we use B to get another piece of information. Our next piece of information is called the phase shift. And these are your first couple problems in your homework too. And that's why I'm doing this one at the beginning and not at the end. So you can go follow along with the videos and still get your homework done. So I'm giving you too much so you can go through and click in and get your answers and stuff with all the things that I'm going over at the moment. So even if it is going over your head, which is fine, just looking at the terms and then being able to match it up with your homework allows you to move on and get to the next piece. And you'll get it. Fake it till you make it. So our phase shift, I use a PS. I'm not sure what your text is. This is your shift. This is your shift. And it ends up being the X is equal to whatever your C value is over your B value. And we're going to talk just a bit more on this phase shift. The phase shift, I'm just going to tell you right now. Graphing sine and cosine is freaking simple until the dang phase shift. It's that C. It's by adding a plus or a minus inside that parenthesis, everything goes to hell. It makes everything so much more challenging. And we'll talk much more about this well, not, I don't know how much more, because I don't go into too much depth. But we'll have some other videos where we're going to go into more depth about just the phase shift and how that looks. But for now, we're going to think about this. This is like our new start. It's like our new start. So, because like we have a sine wave, typically think one period. All right, it goes like this. From 0 to 2 pi. And we think of right here, that's our start. Kind of, right? Like we know it keeps going. There's quotes start because it goes like this. And there's no starting place. But we're saying where we begin. Well, if you had some C over B now, it's saying, well, maybe you're going to start here. It's some different X value. And that's the phase shift. So it's what shifts it like this, right, or maybe it shifts it to the left, not up and down. So the stuff inside the parentheses here, that affects the X values, shifting left and right. That's the X value. So we can just think, like this just affects the X's. The A and the D, that affects the Y values, the up and the down. And then here, the B and the X, see, that affects the left and the right. All right, there's some very basic. I did not go into any sort of depth on this. I just gave you what all the different terms mean. You got your period, you got your phase shift. Got your phase shift on down here. It's kind of like your starting point. You'll even end up with like an end point too. The end is just your period plus the phase shift. Where you start plus how far you're going to travel will tell you where you're going to end. Whatever. There's a lot of stuff to go into. So I'm going to shut up for now. We'll break it down thing by thing. Next time we'll go through amplitude and vertical translation only. And then we'll move into some tough ones. Later.